In 1994, the TD-4100 series oil and water monitors were originally designed with an atmospheric, non-contact, falling stream flow cell to prevent the fouling typical of full-contact flow cells. With the falling stream design, it is important that the stream exposed to the light beam be constant in diameter and laminar flow. The best way to assure constant diameter and laminar flow is with a constant head device we call the bubble trap, also known as a deaerator. Having heard complaints from in-field users of other monitors, we decided that a bubble trap designed with an isolation valve on the discharge to the flow cell would be standard on all models. After a few years' experience, we added an automatic turn-on and shut-off actuator to the isolation valve to prevent splashing onto windows during startup and shutdown. It also reduces maintenance of the monitor windows in the flow cell when the sample flow is intermittent. Note that other makers of falling stream flow cells do not offer this feature. This presentation illustrates the reason for the bubble trap and the auto valve. Note that other manufacturers do not offer either device as standard in order to show a lower price. The end user then suffers from the lack of proper equipment and setup. To illustrate the benefits of the bubble trap and the auto valve, our test rig uses a standard calibration bottle filled with a fluorescing fluid. The water flows down through the bubble trap the same as in a live process. We will use the pneumatically actuated auto valve in the manual mode. In the first example, we start the flow using the auto valve, but end it with the auto valve in the open position. This allows the water to completely drain out of the bubble trap, simulating either a bubble trap with no auto valve or a flow cell with no bubble trap at all. Water on the windows can leave deposits that affect the optical performance of the monitor. If this were salty water, as is often the case in oil production brines, the hanging drop can form salt crystals which can deflect the flow. Vibration, as is typical on shipboard applications, can cause further splashing on the windows. Here's another view of a persistent droplet and some splashing on the windows. Next, we show the effect of a flow start with no bubble trap or auto valve. In this case, the auto valve will remain in the open position while we pour water down through the bubble trap. Note the sloppy start of the water flow in the flow cell. This is what happens with no bubble trap or auto valve. And a clean stop using the auto valve. Now let's watch a nice clean start using the auto valve and watch for the unorganized stop as the water drains without the benefit of the auto valve. Here it is again, frame by frame. This is what happens inside a falling stream flow cell without the benefit of a bubble trap or auto valve. Now one more time, let's watch clean starts and clean stops using the auto valve. No dribbles, no drabbles, and no worries. Turner Designs Hydrocarbon Instruments, world-class products and worldwide field service. Thank you for watching.